So in these nonlinear systems, at least one of the two equations is not aligned. How to approving, and I also indicated that you won't be doing this on your test. So it's good to get an idea of what it looks like, but we're going to focus today on substitution and elimination, which are the two methods that you'll be tested on. So if you could think about what we've covered so far as conics go, we've had parabolas, we've had circles, we've had ellipses, and we've had hyperbolas. If you match these with a line or with each other, you could get more than one answer or no solution like the first one. So if I had a parabola and a line that was below the parabola and not intersecting it, that would be a no solution. If I had something that intersected once, I'd have one solution. Twice, two solutions. Three solutions, or I could even have something that has four solutions, like an ellipse or a circle that's intersected with a hyperbola. Okay, so just to get an idea of the type it can have. And then we talked about how we would graph this. So using the graphing calculator, we would solve it for y, and then we would plug it into the graphing calculator and see where they overlapped. So graphing it, get straight to solving the system algebraically, because that's what you're going to have to do on your test. So there's two options to solving algebraically. The first is substitution, and the second is elimination or the addition method. How many of you remember systems of equation from Algebra 1 or the beginning of Algebra 2? Good. So the difference now is you've got things that are squared thrown in here, okay? So it's not just two lines. So when we do substitution, we solve one of the equations for one of the variables, and then we take whatever that expression is and plug it into the second equation in place of that variable. That's what substitution is. When we do elimination or the addition method, you're going to see the two lines. You want to change one of the equations in a way in which one of the variables would cancel when you add them, solve for whatever variable remains, and then plug it back in. So we're going to do substitution first. So when you're looking for substitution, I would look at these two and see, is there one that's A, already solved for a variable, or B, is easily solved without having to square root it. So when you look here, is there one that's already solved for a variable? Yeah, the second one is already solved for y. So I'm going to take what y equals here, and I'm going to plug it in the place of the y in the first equation. So I get x squared plus 1/2 x squared minus 26 squared equals 100. Now, when I've got an expression raised to a second power, is that 1/2 x squared minus 26 squared, or do I have to expand it and FOIL it? Got to expand it and FOIL it. So this is where it gets a little trickier. This is when your algebra skills are obviously going to come into play. Oh, that's the 26 now. You'd have to square root each of the terms that were there, each individual term. So you'd have to square root the whole side if you could do that. But you couldn't do that with the left side because you've got an x squared plus something. That's not a perfect square. So this would be 1/2 times 1/2, which is 1/4, x squared times x squared, which is x to the 4th. And then 1/2 times negative 26, which would be a negative 13x squared. Negative 26 times 1/2 x squared, which would be, again, negative 13x squared. And then negative 26 times negative 26, which is a positive 676. Yep. All right, so I didn't hit record, but I multiplied everything by 4, and I get x to the 4th minus 100x squared plus 2,304. So these numbers are super huge, right? I don't want to factor. If I did have to factor, they'd probably be smaller, to be honest with you. But you could factor this. The other way of doing this entire thing, so sometimes the obvious is not the way to go. If I had looked at the very beginning, if I want to avoid the expanding and foiling, look to see if there's a way in which I could avoid it. So let's see if we can solve for another variable. Let's say I take that top equation and I solve it for x squared. So this would be x squared equals 100 minus y squared. Now, in the place of the x squared, I'm going to plug this expression in. So I'd get y equals 1/2 100 minus y squared minus 26. I distribute that 1/2. This is 50 minus 1/2 y squared minus 26. 24 minus 1/2 y squared. Now I'm dealing with much smaller numbers. I still have the squared and the non-squared, which means I still have to get everything to one side. Instead of this being negative, I'm going to move it over here so it's positive. 1/2 y squared plus y minus 24. And then multiply everything by 2 to get rid of that 1/2. Now my numbers are way more manageable. So sometimes just the approach is going to lead to different possibilities that one might be easier than the other. Sometimes it's obvious and sometimes it's not. If you get to a spot where you know that you're like, I mean, I could solve that x to the 4th. It would be x squared plus or minus, well, minus, and then x squared minus. It is solvable, okay? But it's obviously dealing with much bigger numbers. So this is a little bit easier. Are there factors of negative 48 that sum to positive 2? What are they? One's going to be positive, one's going to be negative, right? So they got to be a difference of 2. What factors of 48 are 2 apart? 6 and 8. And the bigger one, you want to match that middle sign, so this would be a positive 8 and a negative 6. Set each of them equal to 0, and I get y equals negative 8 and y equals positive 6. Isabel.
I'm just so confused on how you got the numbers to this small.
I tried solving for a different variable. So instead of plugging into something that had to be squared, I solved for the squared variable and plugged the whole thing in. So I didn't have to expand and FOIL.
So we need to solve for x now?
So now, yep, so now I have 2 y's. So there's going to be 2 ordered pairs here. One in which the y is negative 8 and one in which the y is 6. So now I got to plug them both in, okay? You can plug them both in to the very top one. I could plug them into the second one. I can plug them in any of the original equations, okay, is probably your best bet. So if I plug it into here, I'd get x squared plus negative 8 squared equals 100. X squared plus 64 equals 100. X squared equals 36, and x equals plus and minus 6. So this now split into 2 answers. 6, negative 8, and negative 6, negative 8.
So instead of solving for x, you solved for...
So the first time around we used the y. That was already solved. And you could have done it that way, except they were going through factors of 2,304 that sum to 100, which is a lot uglier. So the other option was go back and see if I could solve for a different variable. But I'm not done yet, right? Because I haven't plugged in 6 for the y. So I have to do the same equation, x squared plus y squared equals 100. This time I'm making the y 6. So I've got positive 6, negative 8, negative 6, negative 8. That came from my first set. And now when the y is 6, the x is either positive 8 or negative 8. Ian.
What was the point of doing all the first stuff then? First time?
So sometimes you can solve it the first time. I could have continued solving that. But how many of you know factors of 2,304 that add up to 100? So sometimes you want to go back to the drawing board and see if there's an easier way to do it.
So you just did that just to like...
Because sometimes it works that way. Sometimes you pick the right one. Sometimes you don't.
Okay. And then can you explain what you did with the coordinate points again? After you got one.
So once I solve for the first variable, in this case we solved for y, we got 2 answers for y. I have to plug them both back into x. And in this case, both of those resulted in 2 x's, which means I have 4 total points in which this would overlap.
Okay, but how do you know which equation to plug them into?
It doesn't matter. Either one you plug them into, you would have gotten the same answers. So you want to plug them back into the original ones, but it doesn't matter which one.
Okay, so you did it to the first one.
I did it to the first one just because it was easier than doing a half of a squared.
Okay.
But it doesn't matter.
You said you plugged them into X?
No, I plugged them back into Y.
Okay.
And to find the X.
Okay.
Yep. Lauren.
Does it matter the order, like if you put like 6, -8, or 8, -6?
Yeah. Like, well, I mean, in this case, the 8 and the 6 were reversed.
Yeah,
but
but
so that. But normally, if I had like, if I plug in the 8 for the Y, the 8 has to go in the place of the Y. But how you list those points, as long as this is a point together and this is a point together and this is a point, then it doesn't matter how you list it. So think about like what this original equation would have been, right? So if I look at the original equation, okay, this is what kind of shape an x squared plus y squared equals 100. You know what shape that is? Which one has nothing underneath and they're both squared? A circle. So this is a circle with a radius of 10. Something like that. No, but it's like, think about it. If you could graph it, it could tell you how many points they are and where about they would be. Does that make sense? So it's your way of checking your answers. So a y equals 1/2 x squared minus 26. What kind of shape is that when you have 1 squared? It's a parabola, right? If the x is squared and it's positive, it's opening upward. And a negative 26 means it's shifted down 26 places. So this is a parabola that does something like this. So it should make sense that they overlap in 4 places. Does that make sense? Sometimes it's not going to tell you exact points, but it'll at least get you along the right road.
Do you have to substitute both, or can you substitute one and then check the answers, and if that's right, just keep those?
Say that again?
Like, do you have to substitute?
No, if you were able to factor from here, you'd be done. Like you'd have to factor. You'd get your you'd actually get 4 x's. You'd get 4 x's and you'd take each one of them and plug them back in.
And like if you had started with a different one, like instead of starting with like the.
It doesn't matter which one you start with. You can solve for either equation for either variable. It's just that when you plug it back in, you have to plug back into that same one. Right.
Wait, if you would have gotten 4 x's like for that one, then you would have had to do like you would have had like 8 points.
No, it would be the 4 x's would have given you the same 4 y's. So if I had 4 x's from here and I took them and plugged them in here, each of those is going to give me 1 y. And I'd end up with the same 4 points.
Because all the points would equal something.
Yep. No matter how you approach it, you're going to get the same answer. Try another one. I'll tell you it's a little bit easier. That's the good news. Solve the system equation by using the substitution method. So the first one is x plus y equals -1. The second one is x squared plus y squared equals 25. Let's say you started with the bottom and you solved for an x. You'd end up subtracting and then square rooting. Is that something you want to be dealing with? No. So try to figure out a plan before you even start this, which tells you it's much easier to solve for one of the first ones, right? Does it matter if you solve for x or y first? No, so pick one. What do we want to solve for? Let's solve for y. So we're going to take this equation and we're going to solve it for y, which means subtract the x. Now that I've used that one to solve for, I have to take that and plug it into the y on the second one. So x squared plus -1 minus x squared equals 25. I still have to expand and FOIL, but these will be a little bit easier numbers. So if I expand that -1 minus x times -1 minus x and FOIL it, first is 1, outer is positive x, inner positive x, last positive x squared. And I get 1 plus 2x plus x squared.
When you're factoring, I mean, like, when you split out, they're not factoring, they're just like.
When we put it back in, we're going to have to factor.
So you're not.
So we're foiling out in the beginning so that we can combine terms and get it equal to 0. We have to have it equal to 0 before we can factor and solve it.
Okay.
So I've got to do this step. Now I've got to take this and plug it back in the place of that one. So this is x squared plus 1 plus 2x plus x squared equals 25. As soon as you see a squared and an x, you should know you're going to have to factor. You want to get everything to one side. And make it easy on yourself. Put it in order of highest exponent down to none. So there's